Welcome to the pre-calculus video for skill number 24. I can graphically transform the 15 parent functions. Featured below is a compass, and like most compasses, we have a needle which points north and a needle which points to the south. And today's trivia question is, there's a native word given to the north wind, and there is a native word given to the south wind. Now, I'm sure these words are tribe specific, but there's one that I've learned about. I'm curious if you know it. Alright, on with the lesson. Alright, so the skill we're about to learn is kind of lengthy in notes, and it feeds directly into the next skill, which is to algebraically transform the parent functions. And we have 6 basic types of transformations, and I'm going to cover all 6 of them in this video. This particular video we're interested in graphically transforming a function. So the first type of transformation that we have is a vertical shift. So there's 2 different types of shifts, and we're going to focus on a vertical shift. So a vertical shift occurs whenever we add a number to the end of our function. So if we had a parent function of y equals x squared, and we added a number to the end of it, that means we're going to shift it 3 units up. And so I have the sketch of my original parent function, and then the shift of 3 units up. For this particular skill, we should be really focused on being able to do this. So you have to have your parent functions kind of memorized, because as soon as I say take x squared and shift it 3 units up, you're going to have to know how to graph x squared. I did a couple more examples of vertical transformations. What we've got here is the square root function, and the square root function we have now shifted 2 units down. So when our start point was at 0, 0, we shifted it 2 units down. So we moved down 2 units and graphed from there. And the last vertical shift I've got is of the absolute value function, and this one I just said shift up 1 unit. So we took our start point, which was originally at the origin, and we've moved it up 1 unit. So as you can see, we're going to have to be very comfortable with graphing our parent functions. So if you have note cards is a good way to remember how all of the parent functions are graphed, and we'll want to be able to graph them cleanly. The next type of shift is a horizontal shift, and that's our second of 6 transformations. And the horizontal shift, instead of adding a number to the end, what we do is we modify our x value. So all of our x's get replaced with x minus h. So in the example of our parabola, we had variable squared. That's going to become variable minus h squared. And in this case, we're subtracting 2, so that tells us we're moving 2 units to the right. And I understand that this is negative, but we're still moving right. It seems counterintuitive, so be careful there. Here we go, 2 units to the right, and I graphed it. Did a horizontal shift to the absolute value function as well, and in this case we shifted, you can think of this as x minus -3. So essentially we're going to move our start point to the -3 spot. So we take our absolute value function and we go to the left. The final one is a log function, and this log function is x minus 1, and that tells us move 1 unit to the right. So we did have a vertical asymptote at 0, so that gets moved 1 unit to the right, and now we have a vertical asymptote at 1. And we had a crossing point of 1, and that gets moved 1 unit to the right, so we now have a new crossing point, or x-intercept, of 2. The next two transformations are called reflections, and we have a horizontal reflection, or a reflection over the x-axis. So you can see graphically what I've done is I've taken this image and I reflect it over the x-axis. And the way we do that is we replace x with negative x. So in our original function, which was y equals the natural log of x, and by the way, the natural log is just log with a base of e. We'll get into that again later on in the year, but it's a log function, and we replace x with negative x, and we get the following function. And that function reflects over the x-axis. So you can see how first it opened to the right, now it opens to the left. We also can do vertical reflections, and in order to do a vertical reflection, what we do is we just take our function and negate it. So our entire function gets a negative sign in front of it, and what that does is it reflects it vertically, or moves all of the x values that are positive and makes them, all the y values that are positive and makes them negative. So we see in this square root function we have a curve that curves upward, and then we reflect it or over this line. It's a vertical reflection, and now it curves downward. Part of the process of graphing these nice and clean is we know the pattern for graphing the parent function, and so we would use that in graphing the reflection. Instead of going up 1 and right 1, we'd go down 1 and right 1, and then down 1 and right 3. So again, it's important to remember how to graph our parent functions.
Hi, ich bin's Michel und ich bin Sven und wir zeigen euch heute unseren ultimativen Trick.
Alright, the last two transformations we have are stretches and compressions, and we have both a vertical stretch or compression and then also a horizontal. So first let's talk about vertical. When you are stretching something vertically, you are changing the y value. So you can take your whole function and multiply that whole function by a number. So I've graphed y equals sine x, and then I transformed it by multiplying that function by 3. And what that does is it vertically stretches it. It takes all the y values and multiplies them by 3. So our 0 stays at the same spot because 0 times 3 is still 0. However, the point where y equals 1 now becomes y equals 3. Or when y equals negative 1, it becomes y equals negative 3. So it's vertically stretching all those key points. Then in example 10, I multiplied, instead of by a number greater than 1, I multiplied by a number that is between 0 and 1. So we took our original function and we multiplied it by 1/2. And since that's less than 1, what's happening is it's actually getting compressed. So we're compressing it by 1/2. So when our pattern was out 1, up 1, out 1, up 3, we're now out 1, up half, out 1, up half of 3, out 1, up half of 5, out 1, up half of 7. So you can see what it's done to our parabola is made it a little more squat by taking those points and moving them downward, cutting their height in half. Alright, the final transformation is a horizontal stretch or compression. And this time what we're going to do is, instead of putting a number in front of the whole function, we'll put a number in front of x. So what we put in front of x is 1 over b, and that tells us what's going on. So if our function was y equals x squared, what we're doing is we're replacing x with 1/3 x. And so our b value is 3, right? 1 over 3, 1 over b. So we are horizontally stretching it by a factor of 3. So if our original parabola looked like this, and it was going to be out 1, up 1, out 1, up 3, what we do when we are horizontally stretching it, now we do out 3, up 1, out 3, up 3, out 3, up 5, out 3, up 7, out 3, up 9, etc. So our parabola has become horizontally stretched. And while this may look like a very squat compression, a vertical compression to some people, we should be careful because it's not behaving exactly the same way as a vertical compression. So we should avoid thinking of it that way. In other words, this would not be the same thing as 1/3 x squared. This would be a vertical compression of 1/3, whereas this is a horizontal stretch by a factor of 3. So we've got to be careful with these. Let's take a look at another example. Here what we do is we take our parent function root x, and we've replaced x with 2x. And so what that effectively is saying is we are multiplying x by 1/1/2. And that's kind of hard to see, so most people just stick to taking the reciprocal of the number in front of x. And that tells us that we have a horizontal compression by 1/2. So with our square root function, which typically goes up 1, out 1, up 1, out 3, up 1, out 5, we're now going to horizontally compress it by 1/2. So up 1, right half of 1, up 1, right half of 3, up 1, right half of 5, etc. Horizontal compressions are by far the trickiest ones to learn, and most likely this is where people will stumble. So be sure to head through this slowly and ask me when you have questions. Finally, when we go to doing this graphically, what we can do is we can actually have combined transformations. So here I've drawn a graph of some random function, and we don't have the actual equation to it, but we're told to graph this transformed function. And when I look at that transformed function, I see a couple things. I see that we have moved to the right 1 unit. I see that we have moved up 3 units, and then I see that there's a vertical stretch by 2. So vertical stretch by 2. So if I were to take this function and transform it, one thing I could say is, well, my vertical stretch by 2 is going to make it look more like this. I took all the coordinates that were key and I vertically stretched it by 2. And then what I need to do is I need to transform it, or translate it, 1 unit to the right and 3 units up. So, drawn below, I've gone 1 unit right and then 3 units up. So my start point has moved, and then you can see the stretch is drawn on there. So this is a good graphical transformation where we took a graph and applied 3 different transformations to it. Alright, thanks for watching, and after this video you should be able to graphically transform functions, and we'll focus on transforming the parent functions, but we should also be able to transform really any graph we're given. And the answer to the trivia question, the north wind is called Ka Bib On Oka. Hopefully I'm pronouncing that right. And the south wind is called Sha Wan Desi. And hopefully I'm pronouncing that one as well. Kaba no Oka is the north wind responsible for painting the autumn leaves their colors.